Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 16, 2026, exactly 1 week ago. It introduces a new framework called PEP that achieves about 81% alignment with user preferences, significantly outperforming standard reinforcement learning methods, while requiring 3 to 5 times fewer interactions. The paper is titled, Cold Start Personalization via Training-Free Priors from Structured World Models. And as we'll see later, the fact that it achieves these gains using a fraction of the parameters is really impressive. Figure 1 illustrates the two-stage pipeline that makes this possible. On the left, the offline stage builds a structured world model from existing data, effectively learning a map of how user preferences tend to cluster together. Moving to the right, the online stage uses this map to navigate interactions with new users. It adaptively selects questions to pinpoint the user's position in that latent space, updates its beliefs after every response, and then predicts a full profile to guide the final answer. So, with the pipeline established, Table 1 details the preference alignment results. The scores here report the percentage of oracle performance, where 100% represents perfect ground truth knowledge. First, notice that baselines like prompting and collab LLMs struggle, generally scoring between 20 and 30%. In contrast, PEP consistently takes the lead. On the social IQA benchmark, for instance, it achieves over 87% alignment, significantly surpassing the reinforcement learning baseline, GRPO, which trails at 71%. Now, Figure 2 highlights the efficiency gap by plotting how many baseline queries are needed to match PEP's performance. The dashed gray line represents parity, but the data points soar well above it. For the medical dataset shown in red, just one query from PEP provides as much information as 7 from GRPO. In fact, the text box reveals that for social and common sense tasks, the baseline never catches up to PEP's single-turn accuracy, even after 15 rounds of questioning. Alright, the efficiency we just saw stems largely from how the model reacts to users, which Table 2 measures as adaptivity. This metric tracks how often a different user response actually triggers a different follow-up question. Notice the GRPO column for the AIME dataset, where it scores a flat 0. That means the reinforcement learning baseline just memorized a fixed script and ignored the user entirely. In contrast, PEP consistently adapts between 40 and 60% of the time, proving that it genuinely updates its strategy based on new information. Okay, Figure 3 plots adaptivity against preference alignment to visualize this relationship directly. The green circles representing PEP cluster in the top right, confirming that active adaptation generally leads to better personalization. In contrast, the red squares and purple diamonds for prompting and collab LLM sit low on the chart, proving that interactivity alone is not enough. Meanwhile, the blue triangles reveal that GRPO achieves reasonable alignment despite low adaptivity, likely by memorizing static dataset patterns. Well, Table 3 provides a concrete example of this behavior by comparing interactions with two opposing users. User A, who wants casual chat, and user B, who prefers formal answers. On the left, the GRPO baseline asks identical questions to both people regardless of their replies, failing to find most of their true preferences. On the right, however, PEP adapts immediately. After seeing user A enjoys conversational tone, it pivots to humor and storytelling, but for user B, it switches to formal definitions. This responsiveness allows it to discover every single preference for both users. So, having seen the qualitative difference, Figure 4 quantifies the importance of each component through an ablation study. The red dotted line at the bottom represents the model without any learned preference correlations. It barely improves over the baseline, proving that the latent world model is the most critical part of the system. Meanwhile, the blue line shows the full adaptive method, which consistently outperforms the gray dashed line representing random questioning, effectively saving one full turn of interaction to reach the same accuracy. Wrapping up, 2 takeaways stand out. First, massive reinforcement learning isn't always the answer for personalization. By modeling how user preferences naturally correlate, PEP achieves 81% alignment with tiny models, proving that structure often beats scale in cold start scenarios. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.